In problem number 13, we are trying to make an orbit around planet X. And so we're trying to figure out how fast we need to go to make an orbit if we are 151 meters over planet X. Now, last problem, in problem number 12, you found that planet X had a radius of 942 meters. And we found out what g was when we're standing on the planet, but of course g would be smaller once we're out 151 meters more. 151 meters more is significant when there's only 942 meters. If we were 151 meters above Earth, we'd still be 9.81 because that's not very high. But this is significantly higher in that planet. So our total radius here is going to be bigger. It's going to be the 942 plus the 151. So that would give us a total of 1,093 meters to use as the radius here. Of course, this means we have to have a new g also. So what you can do is plug into the g prime equation using this new r and find out what our new gravity is. And then we plug into the v equals the square root of g prime r, which of course is our orbit velocity equation. And we'd stick this r there and we'd stick our new g there. Or we could do the algebra and stick them all in together. If you prefer that algebraic method, which of course I always do. So if we have g is equal to the square root of g prime r, and we know that g prime is really equal to big G me over r squared, if I stick this in here, clearly this r on top is going to cancel one of those r's on the bottom, and our velocity is just going to equal the square root of big G me over r. So this whole thing is going to be underneath the radical. So the v is going to equal square root, it'll open up a parentheses, you will stick in 6.67 exponent negative 11, and then we'll have times the mass of the Earth, which again was 6.31 exponent 16, and then we're going to divide by our new radius, which again we figured out earlier was 1093. So we're going to have 1093, and then we close the parentheses so everything in the parentheses gets done before the radical does. And if we plug this in like that, we can do this in one step. I always prefer to do things in one step if we can get away with it. So negative 11, oops. Times 6.31 exponent 16 divided by 1093, and we end up with a beautiful 62.1 meters per second. And again, on the little sheet there it says 62.0. Who cares if I say 1 and you say 0? That last number is uncertain. Everybody's happy. And you are now done. If you can do these, you're going to be in great shape. Again, our test is going to be divided into 2 sections. One day, the day that it's scheduled for the midterm, you will have to do at least 10 of these 13 problems, and you'll struggle your way through it, and you'll do great because you've studied these really hard. On the other day, we will have a bonus question, and we will have a short test over Newton's e-wishes. So make sure that you understand 1, 2, and 3, and everything that they entail. You do that and you're going to be in great shape. Those of you who are studying ahead of time, you're going to be doing well because you're going to have a couple days to look over this and it'll get in your head and it's all review. For those of you who wait till the last second and this is the first time you've ever tried to plug it in the calculator, well, good luck. I guess I'll see you next semester.